For the points on the equatorial plane, the magnitude of electric field at the point due to positive charge E plus equal to 1 by 4 pi epsilon naught Q by AB square. This is the equatorial plane and point is at A. This is point B and this is point C, where positive charge is at B and negative charge is at minus Q is at C, and this is the theta angle, and this distance is A from O. This distance is also A, so that the distance between two charges is 2A. So E plus equal to 1 by 4 pi epsilon naught Q by AB square equals to 1 by 4 pi epsilon naught Q by. Now AB will be equals to A square plus R square. So AB square will be A square plus R square. Now E plus vector equal to, taking component form, E plus cos theta I cap plus E plus sin theta j cap, equation 1. Now the magnitude of electric field at A due to negative charge is E minus equals to 1 by 4 pi epsilon naught Q by AC square equals to 1 by 4 pi epsilon naught Q by A square plus R square. Hence E minus vector equals to E minus cos theta I cap plus E minus sin theta minus of j cap, equation 2. Here it is shown, E plus and E minus. Net electric field at A is, net electric field at A, this is E plus and this is E minus, so net will be in this direction, E vector. Net electric field at E is E vector equal to E plus vector plus E minus vector. The E plus cos theta I plus E plus sin theta j plus E minus cos theta I cap plus E minus sin theta minus of j cap, using all value 1 by 4 pi epsilon naught Q by A square plus R square cos theta I cap plus 1 by 4 pi epsilon naught Q by A square plus R square sin theta j cap plus 1 by 4 pi epsilon naught Q by A square plus R square cos theta I cap minus of 1 by 4 pi epsilon naught Q by A square plus R square sin theta j cap. This will cancel each other. So we have, and this will add to each other because both have I cap, equals to 2A by 4 pi epsilon naught A square plus R square cos theta I cap, or 2Q dot, sorry, dot not A, 2Q. 2Q by 4 pi epsilon naught into A square plus R square into, now putting the value of cos theta, the, which is A by under root A square plus R square into I cap, equals to 1 by 4 pi epsilon naught 2QA by A square plus R square to the power 3 by 2 into I cap, equals to 1 by 4 pi epsilon naught P by A square plus R square to the power 3 by 2 into I cap, equals to 1 by 4 pi epsilon naught P by A square plus R square to the power 3 by 2 into minus P cap, because since I cap equals to minus P cap, unit vector, or equals to 1 by 4 pi epsilon naught minus of P into P cap by A square plus R square to the power 3 by 2, equals to 1 by 4 pi epsilon naught minus P vector by A square plus R square to the power 3 by 2. If R is very greater than A, then A square plus R square equivalent to R square, and hence E vector equals to 1 by 4 pi epsilon naught equals to minus P vector by R cube. Dipole in uniform electric field. Dipole in uniform electric field, it is shown here. Dipole, it is electric field in this direction. In this case, it also electric field in this direction, but dipole is in this direction, dipole moment. Net force F vector equal to F vector plus F minus, force on positive charge and force on negative charge, equals to F plus plus minus of F plus, and net torque equals to 0. So tau vector equal to 0, and in this case F vector will be 0, but tau vector is not equal to 0, because there is a direction of dipole moment in this direction where it is shown. P vector makes angle theta with E vector. Now tau vector will be tau plus plus tau minus, tau plus minus k cap plus tau minus minus of k cap F vector. Here it is shown plus, and this is minus charge and dipole moment in this direction. Force on positive charge is in this direction and negative charge in this direction. So there is a torque on this, and this distance is a sine theta. This distance is also a sine theta. So equals to F plus into a sine theta plus F minus into a sine theta into minus of k cap. We have taken anti-clockwise direction as positive and clockwise direction as negative. So equals to QE into a sine theta, because F is QE, plus QE into a sine theta into minus k cap clockwise. So 2QA into sine theta minus k cap, and 2QA is P, so P into E sine theta minus k cap. So we can write P cross E vector. When the dipole is placed parallel to the uniform electric field, it will experience no net force and remains in equilibrium. Also the net torque is 0. If the dipole is slightly rotated from equilibrium position, the net force on it is again 0, but net torque is not 0, and the net torque is given by this formula, this derivation. Dipole in non-uniform electric field. Here we see this is a non-uniform electric field, and there is different situation for non-electric field. For example, here electric field is dense, so force on at this point charge will be more than a point here. First, if the field is non-uniform, dipole is placed along the field, the net force on dipole is not 0. When field is parallel to E vector, net force is along increasing field direction, and when P is anti-parallel to E vector, net force is along decreasing field direction. Now Gauss's law. The net flux of electric field through any closed surface is 1 by epsilon naught times the total charge enclosed by the closed surface. That is phi equals to q by epsilon naught, or integration close integration E vector dot ds equal to q by epsilon naught, equation 1, or integration E ds cos theta q by epsilon naught. Now if theta equal to 0 degree, then integration E ds q by epsilon naught. This implies E into integration ds equal to q by epsilon naught, or Es equal to q by epsilon naught, equation 2. For example, here different charge is enclosed by a surface. So net electric field will be net flux will be charge enclosed, that is q by epsilon naught. Now charge enclosed is this q1 plus q2 minus q3. So we have written this total charge by epsilon naught. Proof. Consider a point charge q is placed at the center of a sphere. Consider area element delta S vector on the surface of a sphere. The flux through an area element delta S is delta phi equals to E vector dot delta S vector equals to 1 by 4 pi epsilon naught q by r square into r cap dot delta S vector, or delta phi equals to 1 by 4 pi epsilon naught q by r square into delta S. Since r cap dot delta x mod of r mod of delta s vector into cos theta, or 1 into r into 1 into delta s into cos 0, 1 into delta s into cos 0 equal to delta s. The total flux through the sphere is obtained by adding of flux through all the different area elements. Hence, total flux phi equal to sigma all delta s delta phi, or phi, this implies phi equal to sigma all delta s q by 4 pi epsilon naught r square into delta s equals to q by 4 pi epsilon naught r square sigma all delta s into sigma delta s q by 4 pi epsilon naught r square into s. Hence, equals to q by 4 pi epsilon naught r square into 4 pi r square. And now 4 pi r square will cancel, so we are left with q by epsilon naught. Hence, total flux is equal to charge enclosed by the closed surface by epsilon naught proved. Question: prove that the total flux through a closed cylindrical surface in uniform electric field is zero. First, this is the cylindrical surface, which is cylinder, which is placed in a uniform electric field as shown in the figure. The electric field is in this direction. From Gauss's law, phi is equal to q by epsilon naught. So equals to, because no charge is enclosed in the cylinder, so total charge is zero. So 0 by epsilon naught equals to 0. Now second method, phi equals to phi 1 plus phi 2 plus phi 3, that is flux through surface 1, flux through surface 2, and flux through surface 3. Surface 3 is curved surface. So we can write E vector dot S1 plus E vector dot S2 plus E vector dot S3, or ES1 cos 180 plus ES2 cos 0 plus ES3 cos 90, or minus of ES1 plus ES2 plus 0, or minus of ES plus ES equal to 0, since S1 S2 equals to S. Say, application of Gauss's law. Field due to an infinite long straight uniformly charged wire. Consider a cylinder, Gaussian surface of length L with axis coinciding with the axis of the line charge as shown in the figure. Since the field is everywhere radial, flux through end 1 and 2 will be 0. End 1 means this end and this end, and only flux will be this curved surface. The net flux through the cylinder phi equal to phi 1 plus phi 2 plus phi 3 equals to 0 plus 0 plus phi 3 equals to integration E vector dot ds vector integration E ds cos 0 integration E ds integration E into integration ds, or equals to E into 2 pi r into L equals to E into 2 pi r L, equation 1. Now charge enclosed by Gaussian surface is q into lambda L, where lambda is the linear charge density and L is the length of cylinder. Now from Gauss's law, phi equal to q by epsilon naught. Hence E into 2 pi r L into lambda L by epsilon naught. This implies E equals to lambda by 2 pi epsilon naught r, or E proportional to 1 by r. Or in vector form, we can write E vector equal to lambda by 2 pi epsilon naught r into n cap.